他说他每天他今天会讲到一些东西
对
，trigonometry。
对，这还是把他拉过来吧。他会讲这些基础题，对吧？拉过去上课。哦，OK，充电器啊里面有个电脑充电器。OK，那电脑充电器这个没有。Where's Ethan? He said he'll be. Okay. Anyway. 我得拿手机。Is that? 30. Oh, no. No. Make out last lesson. I make out last lesson. Oh, no. I didn't show up. I didn't show up. Oh, you also didn't show up. Good. Hey, how are you? Good. Will said. All right. Well, that's beautiful. Yeah. No, I already have this. Huh? No, module 3. That's module 3. So today we're gonna start a new module, which is module 3. So module 3 is trigonometry and circular function. All right. All right. So basically, in module 3, we have a trigonometry, circular function, and the circular function graphs. Okay, that's 4 big chunks. All right. So today we're gonna start from the very basic one. Do you guys remember anything about sine, cosine, and tangent? Yeah. Do you remember the SOHCAHTOA? Sorry. Opposite of adjacent. And all that kind of stuff. Yeah, that kind of stuff. Yeah. But I remember why I forgot. All right. I believe we've learned this SOHCAHTOA before. Yeah. It's that. Yeah. I actually forgot. Yeah. Yeah, I need to be more conscious. Yeah. So basically, so wait. Wait, Jesus. This is the updated. This one is updated. Oh. So SOHCAHTOA basically sine. Sine is opposite over hypotenuse, right? opposite over hypotenuse. And cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent, right? Now, I have a question for you. So we have this triangle, A, B, and C, okay? If I want to define this angle as theta, could you please tell me sine theta is equal to which side over which side?
Well, B of the C.
Sine theta.
Yeah. Opposite over hypotenuse.
Yeah, so which one is opposite?
B.
B. So it's a B over C, right? Cosine. Yes, basically that's hypotenuse. It always opposite to the right angle triangle, and that's the longest side.
Yeah.
Yeah, yeah. What about cosine theta? It's adjacent A over C. What about tangent?
B and A.
Yes, so it's a B over A. Yeah, yeah. Anyone learn physics in this classroom? No? No, okay. Anyway, okay, so that's the basic. So sine, cosine, sine, cos, and tangent, right? So basically, there's one more thing I would like to mention. I'm not sure if you know this equation. Basically, tangent theta is equal to sine theta over cosine theta. Anyone remember this? Yeah. So why tangent theta is equal to opposite over adjacent? Have you ever think about this question? Why tangent theta is equal to opposite over adjacent? Any idea? No. Okay, basically, all right. Sine theta is equal to opposite over hypotenuse, right? And cosine theta is equal to adjacent over hypotenuse, right? So we have O on H divided by A on H, which is equal to O on H times what? H on A, right? Does it make sense? Then we cancel the H. So tangent theta is equal to O on A. That's how we get the tangent theta. Any questions? No? Sean, you good?
Yeah.
Okay, cool. Let's move on. All right, so basically, the trig relationship basically describe the relationship between angle and sides, okay? Pythagoras theorem basically describe the relationship between the sides, okay? You cannot use the Pythagoras theorem to find out the angle, okay? It's the relation of three different sides. All right, now let's do this together. Find x, right? So we have x 30 degree and 2. Length is 2. So basically, which trigonometry relationship we want to use to solve this? Sine, cosine, or tangent?
Cos.
Cos, good. So cos 30 degree is equal to, okay, give me a year out.
3 and 6. 3/6.
I mean this question.
Oh,
Yeah, this question. This one. So cos 30 is equal to
2/8.
2 on 2 on x. Okay. So cosine 30 degree, if I use CAS to calculate cos 30 degree, cos 30 degree is equal to square root 3/2. Okay, use CAS. You can find cos 30 is equal to 2 is equal to square root 3 on 2, which is equal to 2 on x. And then we can find x is equal to 4 square root 3/3. Okay. Okay, next one. Example 2. Which relationship we need to use? Sine, cos? Good. Very good. So cosine theta is equal to
3/6.
3/6. Very good. Then if we use CAS, don't worry about it. We're gonna have lessons regarding how to use CAS. Okay. When you use CAS, you should use cos -1, 3 on 6. Okay, just put that into CAS, which is equal to pi on 3, which is equal to 60 degree. Any questions? Sean, you good? Yeah. Okay. Noah, are you good? Okay. All right, let's move on. This is a exam. This is an exam question. All right. I'll give you 30 seconds to read the question. You finished the reading? Still reading. Still reading. Okay. Finished? Finished the reading? Sean, you finished the reading? Okay. So basically, the question asks to find the coordinates of t in terms of theta. All right. Basically, the coordinate of t. That's x, y, right? T, the coordinate of t, x, y. So basically, we want to find the y coordinate. Let's say this is h. All right. And we want to find this. Okay. This is 2, right? We already know this is 2. We need to find out this part. Let's say this part is B. Okay. So how to find it? So basically we can have, because we need to find the coordinates of t in terms of theta. So we need to use that theta, the angle theta. All right. So we have sine theta is equal to h/2, right? Sine theta is equal to h/2, right? Then we have cosine theta is equal to b/2, right? Okay. Now we rearrange this equation. So h is equal to 2 sine theta. And this one, b is equal to 2 cosine theta. All right? And then we can put into the coordinate t, x, y. Basically, give us, okay, so the x coordinate is this part plus this part together, right? Which gives us the x coordinate. So x coordinate is 2 plus 2 cos theta, comma, and y coordinate is just 2 sine theta. That's it. You got 1 mark. Any questions?
Yeah.
Huh?
I don't get it.
You don't get it? Okay. Okay. Sean, does it make sense to you?
Somewhat, yeah.
Somewhat? Okay. All right. Noah, you good with this one?
Kind of.
Kind of. Okay. So basically, we want to find the coordinate of t, right? We want to find the coordinate of t. So if I draw a triangle here,
Like find x and y.
yes, x and y coordinate,
Yeah.
all right, in terms of theta, right?
What is in terms of theta?
Basically, it's in terms of theta, basically theta could be changed. So like, how to explain in terms of theta?
So I need to worry about
Like theta is something you don't know, but you just assume it's a given value, but the given value is you don't know the exact value.
Okay.
Okay. So basically, if I draw a triangle, is that a right angle triangle?
Well, what? It's a right angle triangle again. Or the square.
Right angle triangle means one angle is 90 degree.
Oh yeah, yeah.
Yeah? Is that right angle triangle?
Yeah.
Okay. So we want to find the length of this side. We just call it h. Okay, we want to find h. And we want to find the length of this side. We just call it b. Okay. We have angle. This is theta. All right. Now, can you find the... Okay. So sine, if I write sine theta is equal to which side over h over
B over B.
over b?
Oh wait. Over what is it?
Which one is hypotenuse? Which one is
Wrong
hypotenuse?
side.
Okay. This is the triangle, right? Okay, that's h. That's b, right? That's theta. Which side is hypotenuse?
The others.
Give me 1 second. Okay. Okay, this is h. This is b. This is theta. Which one is hypotenuse?
Wait, hypotenuse is the wrong side, right?
Yes. Is that b hypotenuse?
No,
Is that h hypotenuse?
no.
So this is hypotenuse,
Yeah,
right?
I said that wrong side.
Oh, sorry. I did. So can we find the length of hypotenuse?
Yeah.
Yes, which is
Si-
the radius
True.
is 2, right? It's given in the question.
Oh yeah.
Yeah.
Oh, H is 2.
No, h is not 2. Hypotenuse is 2. That's,
I mean the capital H is 2. Yeah.
yeah. So basically that's 2, right?
Yeah, yeah, yeah.
Yeah, that's 2. All right, so sine theta is equal to h over 2. Okay. Cosine theta. Cosine theta is equal to 2 over b or b over 2? B over 2. Right? So that's why we have sine theta is equal to h over 2. Cosine theta is equal to b over 2.
Both of them.
Yeah, we need both of them to find the x and y coordinate.
Oh,
Right? Right? So h is the y coordinate, right? Is it?
oh, wait, I get it.
Yeah. You get it?
Wait, but is that a formula on the bottom?
Yeah, that's the final answer. That's the final answer. Answer.
Different.
Yeah.
Okay, how you get the final answer?
We rearrange h. Basically, h is the y coordinate, right? H is the y coordinate, right? It's equal to 2 times sine theta. I rearrange this equation. H over 2 is equal to sine theta. So h is equal to 2 times sine theta. Is that right?
Because you want h by itself.
You want a h? Yes. H is the y coordinate.
So 2 times both sides by 2.
Yes. Okay.
And get the bottom stuff.
Okay. Let's say 4. Okay. 4 is equal to h over 2. Right? So h is equal to
What, wait,
2 times 4.
yeah.
Same thing. Same thing. Algebra.
Oh, okay, yeah.
Yeah?
Yeah.
Yeah. Okay. Any questions? Sean, you good? Yeah. Okay, let's move on. All right. So let's move on to the next bit. Okay. All right. So in this 3.0, we're going to talk about like how this concept of circular function is derived from trigonometry and what's their difference. Okay. All right. So basically, the trigonometry is just to turn the angle into a length ratio. Okay. Basically, sine 30 degree. So that's degree. That's the ratio of two sides. Okay. That's theta. Okay. That's the angle. And that's the ratio of two sides. Okay. Basically, we use something, we use a rule to convert an angle to ratio of two sides. Okay. Now let's have a look at this question. We have a triangle. Let's just assume it's like a ramp. It's like a ramp. It's theta in degree steeper or 30 degrees steeper. Basically, it's theta greater than 30 degree or theta less than 30 degree. Okay, that's this question asks for. Okay, which trig relationship we should use to figure out this question? Tangent, good. Tangent theta is equal to 2 over 3. Okay, which is approximately equal to 0.67. Okay, I think tangent theta is. And then tangent 30 degree is equal to square root 3 over 3, which is equal to 0.577. Okay, so basically 0.67 is more than 0.577. So we can conclude theta is more than 30 degrees. Does it make sense? Yeah? Yeah, no, are you good? Sean, Ethan?
Yeah.
Yeah, okay, let's move on. All right. Okay, so basically we cover the very fundamental concept of the trig, but trig has its weakness, okay? For example, we can only use that in a triangle, all right? So any angle, let's say that's theta, or that's theta, doesn't matter. So the angle, we cannot have this angle more than 90 degree, right? We cannot have this angle more than 90 degree. Even you have very like thin, tall triangle, but the angle still less than 90 degree, right? So basically we want to lift this restriction on input, but still needed the definition to adhere to the definition of trig. So circular function is invented, okay? There are 3 dimensions, okay? Circular function has 3 dimensions: theta, sine theta, and cos theta. Only 3. Do you have a like? So now you may think, where's the tangent theta? What about tangent theta? Why we only put theta, sine theta, and cosine theta here without tangent theta?
Because tan beta equals sine beta over cos beta.
Good. Tangent theta is defined by sine and cosine. Very good. Okay. So basically tangent theta is not a new dimensions. Okay? Okay, now let's move on to circular function. I'm pretty sure you learned this at school, right? Yeah, Noah?
Oh, yes, yeah.
Yeah, Sean? Okay.
Actually, go to copy.
Okay, okay. This is the circular function. Basically, right? It's called, I think, it's not, I think, it's called unit circle, right?
Yeah.
Basically, the radius is equal to 1, right? The radius is equal to 1, okay? If the radius is equal to 1, okay, so we can have sine theta, okay, sine theta is equal to, so this is theta, right? This is theta, right? This is theta. Theta is equal to opposite over hypotenuse, right? Basically, opposite is the y coordinate, right? For example, point P. Point P, that's y. That's x, right? So opposite over hypotenuse, which is equal to y over 1, which y. And cosine theta is equal to adjacent over hypotenuse. So that's adjacent, right? That's hypotenuse. Basically, adjacent is your x value, okay? So cosine theta is about x. Okay. And if we look at this question, if we look at this graph, so we have A, S, T, and C. Okay, so it's about positive and negative. I'll explain this. A means all. Okay, so basically in first quarter, we have both sine, cosine, and tangent positive. Okay, so in this quadrant, wait. These are all positive. Okay, and I'll show you how to remember it.
I remember the bar.
Okay, just let me explain this and I'll teach you how to memorize it. Okay, and for this one, only sine positive. Okay, cosine, tangent are all negative. All right. For this region, only tangent positive. Okay, and for this region, I know it's really hard to see, but I don't have much option. Okay, only this pink, only cosine positive. Okay, so I'll show you how to memorize this. Okay, A S T C, which means all, only sine positive, only tangent positive, only cosine positive.
I just say add sugar to coffee. Oh, that's how you remember it. Well, I like remember plus. I remember plus minus.
Yes, you can, but just like you need to know what A and S and T and C stands for. So A for all, basically sine, cosine, tangent, they're all positive. S means
Yeah, I know. I remember. Oh, S is like if it says S, then the
only
is
sine
positive.
only sine is positive.
Yeah, of course. That's how you remember it.
Yeah.
Yeah.
And T means only tangent positive. C means only cos positive. So ASTC, all schools teach crap.
Yeah, I said add sugar to coffee.
Okay. Anyway, is that easier to memorize?
That's crazy. That's good. One.
Include this school as well. All right. All schools teach crap. Do you know where I learned this from? All school teach crap?
No.
From my mentor teacher when I was doing my placement.
What my mentor teacher? Oh.
From my mentor teacher. My mentor teacher said, just tell students all schools teach crap. They will memorize it like forever. All right. So ASTC. Okay. All good, Sean? Yeah. Okay. And don't worry about example 7. It doesn't make sense to me for this type of question. All right. Let's move on to the next part. Next part. We're gonna do the conversion between degree, radian, and angle. All right, from here, we're not gonna use degree anymore. Okay, we're not gonna use degree anymore. We use radian. Okay, we use radian. So basically, for convenience, we define the flat angle or some, I think it's called, do you call straight angle or flat angle or both? Both. Okay, flat angle to be 180 degree. Have you think about why we use 180?
Why? Because 290s. Two right angles.
Yes, yes, kind of, but because 180 can be divided by 2, 3, 4, 5, 8, and 9.
About 6.
And yeah, of course, 6. So 180 can be divided by a lot of numbers. So we use 180. Okay. And the weakness, the number is too big. Okay. So we use radian instead of degree. Okay. So the radian is equal to arc length divided by radius. Okay, it's equal to arc length divided by radius. Okay, so let's have a look. So how we convert radian to degree? So basically, if we have, that's a circle, right? That's a circle here. We have a circle here. how to find the circumference of the circle? It's 2 pi r, right? To find the circumference of the circle, right? So
Wait, circumference is how like that.
yes, the length of the circle, right? So it's 300 degree. Jeez. So 360 degree. So we want to find the circumference of the circle is equal to 2 times pi times r, right? That's how we calculate it. And if I divide it by r, okay, so 2 pi r, 2, oh, geez, 2 times pi times r, that's the arc length, right? That's the arc length of a whole circle. And divided by r, all right, which is equal to 2 pi. So that's why 360 degrees is equal to 2 pi. And 180 degree is equal to pi. All right, does it make sense? Yeah? Okay. All right. So basically, we have some common equal to pi over 6. 60 degrees equal to 3, 45 degrees equal to pi over 4, and 90 degrees is equal to pi.
What is the C?
C. Good question. Why we put a C here? Because we use that C to represent this is a radians. This is a radian. Okay. Technically, without that C, pi over, let's say pi over 2 is equal to 3.14 divided by 2 without the C. Okay, with the C, let's say pi over 2, pi C over 2 is equal to 90 degree. Technically. Okay, that's just a convention. But when we do the trigonometry questions, we assume pi over 2 is 90 degree, not equal to 3.14 over 2. Okay, does it make sense? So to be clear, we put a C to represent pi over something is degree, not a number. But when we do like math method exam, especially trigonometry question, we just assume it represents a radian, not a number. Does it make sense? Sean? Yeah, so technically we don't need to write the C. But sometimes if we want to, but anyway, don't worry about it. It's just a format.
Yeah.
Yeah, it's just a format. Now, convert to degree. 3 over 2 pi minus 2 on 3 pi and 7 over 6 pi. Okay, so convert degree to radian and to the radian to degree. Okay, if we have radian, can anyone remember how to convert degree to radian? No idea? Okay. Radian is equal to degree times pi over 180. Okay, and degree is equal to radian times 180 over pi. Okay, that's two equations to show how to convert radian to degree and degree to radian. Now, give you a few minutes to do example 8 and 9. Convert radian to degree and degree to radian. Question A and question 9. These two.
Just write it on my notebook.
Oh, you can write on your book, of course.
What formula I use?
Convert to degree, right? Convert to degree. So you want degree. So you use degree is equal to. So that's radian, right? So these are radian, right? Degree is like 27 degree or 180 degree. Okay. Radian is like 2 pi. Sorry, 2 pi or pi on 2 or 3 pi on 2. These are radian. So you just need to memorize. If it has a pi, it's radian. Okay. I know there's a lot of calculation. No, you got question? No.
Wait, what is pi against 3.1 something? Is it?
Okay, if in trigonometry, pi is not 3.1.
90 degrees.
Pi is 180 degrees.
Oh, yeah.
Yeah.
Oh, yeah.
Yeah, pi is 180 degrees.
No,
Oh, I'm trying not to use your calculator.
I'll Wait, I don't know. I'm stuck with the fraction. Don't worry.
Yeah, I know. That's why I don't want you to use your
Wait,
calculator.
2 times 4, 2 times 2 was a plus. Fractions. Me too. What is it? Is it 2 times 2 or is it 2 plus 2?
What's the same denominator, so
Is it plus 8 times? It says times. Oh yeah, I'm gonna check.
All right, guys, you guys really need to practice your fractions. All right. fraction. All right. 3 times 2 over 3 is equal to,
1 times 2 over 3.
okay, I'll show you the shortcut.
9/3.
Oh, yeah, definitely.
All right? Because 3 times 2 over 3 is equal to 3 times 2 over 2. Right? Sorry, 3 times 2 over 3. We can cancel that, which makes this one is 1, this one is 1. Basically, it's 2 over 1 is 2.
Yeah.
Right? Right? Is that right?
Yeah.
Yeah. Now, I'll wrap it up. Okay. First question, convert to degree. 3 over 2 pi, convert that to degree. We need to times 180 over pi, right? Times 180 over pi. Is that correct?
Yeah.
Yeah.
Yes. Now,
But isn't pi 180?
So it's only 1, so 3 times.
wait. Sorry, no, what's your question?
Isn't pi 180?
All right. So
That's
basically,
1 times 1.
these two can be canceled, right?
Oh, yes.
Yeah. Is that right?
Yeah.
Now, what about 100 and 180 and 2? That's 90.
Five.
That's 1. Right? So the question becomes 3 times 90, which is equal to degree. Right? Is that like, do you guys feel better when calculate the fraction?
Oh, yeah.
Yeah, no one?
Yeah.
Yeah, okay, now, next one. Next one. Negative 2 on 3 pi times 180 over pi. Is that correct?
Yeah.
Yeah, okay, tell me which two can be canceled out?
Oh, pi.
Pi can be canceled out. Okay, next step,
3.
3 and
180.
180, right?
Yeah. So negative 2 times 60.
Yeah. 6.
Is that faster?
Yeah.
Okay. Next one.
Wait, I didn't want to answer. Yes, yes. Okay.
Yes, can I wrap it off?
Yeah, I'll be off.
Okay, next one. I'll give you, next one is a bit hard. Next one is not easy.
What's the 210?
Sorry?
Is it 210?
Good. 7 on 6 pi times 180 over pi. Again,
Cross out pi.
cross out pi.
That's 6. Yeah.
What's that equal to? 180 divided by 6.
What's that? Okay, I'll do it. Oh, yeah, 30. But I was guessing 30.
30.
I should have said it.
And 30 times 7? 210.
Yes. 3. Oh, yes, sir.
Ethan, do you need a calculator to figure this out?
Nah.
Good.
Wait, but like I'll be guessing, so I don't know.
Mhm.
Probably. Oh, I mean, I can. Yeah, I can. It's just time wasting.
Yeah. Yeah. All right, can I rub it off?
Yeah.
sometimes I prefer use whiteboard. All right. I just give you the answer, okay? I'm not gonna repeat the process here. So this one is a 270 degree. This one is a negative 120 degree. This one is 210 degree. Now, next one, convert to radian, okay? So when we convert to radian, we have a degree, right? We want to convert to radian, okay? So degree times pi over 180 is equal to radian, okay? So 150 times pi over 180. Use the same technology. Can I cancel the pi?
No.
No. So it's something pi, right?
This is 450.
If I divide it by 30, 150 divided by 30 is equal to 5. 180 divided by 30 is equal to
6.
same thing. Negative 180 degree times pi over 180, which is equal to negative pi, right? Because these two basically cancel, and that's negative 1. Okay?
Wait for the first question. How do you do it?
Okay. So it's equal to 150 pi over 180. Okay. If I divide it by 30 and divide it by 30, which is equal to 150 divided by 30 is 5 pi, and 180 divided by 30 is 6.
Wait, well, how do you get 30?
This is a common factor.
30 is the common factor.
Oh, you make out come back.
Yes,
Oh.
you need practice. Yeah. All right. Okay, I want to rub it off, otherwise I'm running out of space. All right, so 390 degree times pi over a 180, which is equal to 13 over 6 pi. Okay, 225 degree times pi over 180, which is equal to 5 on 4 pi. Okay. Okay, it's just algebra. And don't worry about example 10. I don't think example 10 is a good example. It just makes you confused. All right, so don't worry about example 10. It's just confuse you. Okay. Any questions so far? Sean, you good? Ethan? Huh? Okay. No, are you good? All right, let's let's have a like 7 minutes break. We're gonna just come back at 5:30. Okay?
Yeah, so much.
Algebra, guys. Algebra. Fraction.
Let's leave it.
This is the model test one model test. Try your best to finish, and get back next week.
Thank you.
这个更冷，做不了这个，他给你开空调，房间里的那个，那那么热。哦。 给他这个。也算是。后面得有，我有啊，然后晚上都有录呀。有，真的都算。我第二三个的嘛，就是那个最简单的，就是什么，第二三个的那把我买录不做的。你说 Excel 那个是吗？对啊，你拿个简单它都做。我说的是更简单，更简单，更简单我也有，我有那种就是会判断的，不想让大家人这种初级的我也不是。但是什么小点儿啊，我们破号啊，带破号的一些，他们弄不还是有有。现在一个小学口算有一个，我也。你要多少道题？100道、500道、1000道。再有一个，哎，那准备是设的try best to finish in one week actually。
就。Test.
Yeah, further, much further. On.
What I mean, leave for. Still life story.
I'm so lost, but I'm comfortable with the issue.
Life is hard. Wait, I don't. Is that the Gold Coast?
Oh no, right? When I was just like, there is something to
Actual sea. I should catch this. The okay. Yeah.
We actually not know that money.
Wait. Is this negative VO2 or is it just VO2?
Wait, what? Where?
This,
That's very good too.
yeah.
All right. Okay, let's move on. All right, let's move on. So basically, sine, cosine, and tangent is an operation, just like a function. All right, just like a function. You put something in, you get something out. Okay, that's sine. Sine, cosine, tangent. Just assume it's not assuming. It's just an operation. All right. Just like you have square root something. All right. If you have like square root a number, like square root of 4. Okay, so the operation is square root. Okay, the result is 2. Right? Something to the power of 3 cubic. Your input is 2. Your operation is to the power of 3. Your result is 8. Okay. Same. Sine pi over 6. Your input is pi over 6. Your operation is sine. Your result is 1 on 2. It's half. All right. Does that make sense? Yeah? Okay. All right. There are some typical numbers. We should memorize them. So pi on 6 is 30 degree. Pi on 4 is a 45 degree. Pi on 3 is 60 degree. Okay, that's some like typical number we should memorize. Okay, and if we move on to next page, I would expect you guys to memorize all these numbers.
Oh yeah, I used to remember this.
Yeah,
Wait, did not I? Oh yeah, I think I did.
yeah. Because if you memorize these numbers when you do the exam, you can finish the question much quicker. All right?
What's
Uh,
that table called again?
Huh?
What's that table called again?
It's,
Table of values.
it's just a table to show the different values. So basically, how to memorize these numbers? So basically, I just memorize, okay, the first one is sine, the second one is cosine, and the last one is tangent. Okay, and pi on 6, that's 30 degree, that's 45 degree.
Sing a song. I sing a song on this.
Okay, sing it.
It says not spot. I read this a song.
Really?
Yeah.
Can you remember how to sing it?
No.
Okay, basically, I just memorized sine, cos, tan, 30, 45, 60, which is pi on 6, pi on 4, pi on 3. Okay. If we look at here, if I draw a diagonal line, these two numbers are same. Okay. And these two numbers, same. These two numbers, same. Okay. For tangent, tangent is a bit special. One is easy to memorize, right? One is easy to memorize. Then we have square root of 3 over 3 and square root of 3. Tangent is a bit hard to memorize. That's how I memorize them. I hope that could help you to memorize them, memorize these numbers. Okay. Or you can memorize with understanding. Okay. So we have, based on the Pythagoras theorem, if that's 1, that's 2, that must be square root of 3. Right? And that's pi over 6, that's pi over 3. Okay. So sine pi over 6 is equal to 1 on 2. Basically, it's 1 on 2. Cosine pi over 6 is equal to square root of 3 on 2.
There's another table that looks like that. Like, well, there's another table, but it's different. It's the same, but it's different.
Yeah,
Is it the difference? Not the same.
It's different numbers, but it's the same thing. It equals the same thing. Like, it's like a second table.
Yeah, I think I know what you mean. I'll show you later.
Yeah.
I think the table also include the pi on 2, right?
Oh yeah, I think so. I'm not sure.
But there's another way to memorize pi on 2. I'll show you later. There used to be a big table, include pi on 6, 5 pi on 6, pi on 2, 3 pi on 4, but we're not gonna memorize that big table. It's really hard to memorize that big table. Okay, memorize these first, and I will show you how to memorize the other numbers. Okay, now are you good? Yeah, okay. All right. So why we want to memorize the diagram, not the triangles? Okay. Triangles help with understanding plus finding a pattern, but it's slow. Okay. So it's not useful. So we need to memorize the charts and evaluate values straight away. Okay. Otherwise, in your exam, you're going to spend too much time to find out this number. Okay. Try to memorize them. All right. Now evaluate sine pi on 3. Anyone remember what sine pi on 3 equal to? Yes, which is equal to?
Root 3 on 2.
Right? Which is equal to square root 3 on 2. Okay. So this type of question, next class, next class, I'm gonna ask you guys to write down all these numbers. Okay, memorize them. All right. Okay. Next one. Okay. Next one, for the next part, we're gonna focus on 90 degree. Okay. So that's the unit circle. I believe you guys are familiar with this unit circle. Okay, we have number 1, number 2, number 3, and number 4. Okay, we just focus on sine and cosine. Don't worry about the tangent too much. Okay. At position is equal to, sine is about x or y? Sine theta is x coordinate or y coordinate?
X.
Okay.
Or what?
Okay, let's go back to here. Sine theta is the y coordinate, right? Cosine theta, that's theta. Cosine theta is x coordinate, okay? So if we come back to here, so at position number 1, sine theta is equal to 0, right? Because y is equal to 0. And cosine theta is equal to 1, right? At position 2, sine theta is equal to,
90.
yeah, sine 90, which is equal to 1. But cosine theta is equal to 0, right? Position number 3, sine theta is equal to, yes, which is equal to, sorry, 0.
None.
Oh, okay. Okay, basically, this circle corresponding to the graph. Okay. Like position 1, sine theta is equal to 0, right? Y is 0. So position number 1, y is 0. Okay. At 90 degree, which is position number 2, the y value, sine theta, at position number 2, y value is equal to 1. So that's equal to 1. Okay, and then back to 0, -1, 0. All right, that's how we link the graph to the unit circle. Okay, so I really want you guys to memorize these graphs. Okay, so we have some special point. Okay, the first one is 0, 0. For the sine graph, when x is equal to 0, y is equal to 0. And then when x is equal to pi on 2, so that's pi on 2, y is equal to 1. When x is equal to pi, y is equal to 0. And that's 3 pi on 2. Okay, y is equal to -1. And then 2 pi, y come back to 0. Okay, same with the cos. Okay, cos at position 1, when x is equal to 0, y is equal to 1. Okay, when x is equal to 0, position 2, when x is equal to pi on 2, y is equal to 0. Same thing. And tangent. Okay, but the difference between sine, cosine, and tangent is for sine and cosine, 2 pi is 1 period. That's 1 period. Yeah, that's 1 period. Just 1 period. And this one is 1 period, same. Right? That's 1 period. 1 period is 2 pi. 1 period is 2 pi. Okay, but for tangent, that's 1 period. 1 period is pi. Okay, does it make sense? No, are you good? Okay. Okay. So next time, when I ask you what's cosine pi on 2 is equal to, you just need to think about the graph and tell me sine pi on 2 is equal to 1. Okay, does it make sense? Sean? Yeah. Ethan? Noah? Okay. Yes?
Memorize this.
Yes, try to memorize this. If you can memorize these graphs, when you solve the problem, you realize you just need to spend a little bit of time on the calculation. It can make your solving process way faster.
Yeah, I know where to use it.
I'll show you.
Okay.
Okay, I'll show you. Okay. Okay, for example, evaluate sine pi on 2. Sine pi on 2 is equal to, Ethan? Which graph we need to use? Sine graph, right? First one. Pi on 2, when x is equal to pi on 2, y is equal to
1.
1, right? It's here.
Oh, yeah.
Yeah, that's how you use it.
Okay.
That's how you use it. That's equal to 1. Just use the graph. Okay, cosine pi. Ethan, use the graph.
With -1.
Good. You use that one, right? Do you?
Yeah.
Okay. Sean, sine pi.
I don't know.
Which graph we need to use? The sine graph, right? Okay. When x is equal to pi, what's the y equal to? If you look at the graph.
0.
Yes. Right? When x equal to pi, y is equal to 0. So sine pi is equal to 0. Okay, now, Noah, tangent pi on 2. This is a tricky one.
-1.
Look at the graph. Look at the graph. Tangent pi on 2. What this dotted line represent? Asymptotal. Asymptotal means you can never ever get that number.
Also, it's nothing.
It's undefined. It's undefined. No, are you good? Yeah, does it make sense?
Yeah.
Yeah. It's undefined because you cannot have this. Okay, it's impossible to get that number. Okay. Now you know how to use the graph to
Yeah.
figure out.
Yeah, write this down.
Huh?
Write this down.
I think you're gonna have the notes, right? Do you?
Oh,
I mean, you will see this document after this class finish. Okay. All right. So basically, sine x, that's the graph we just had a look before, but basically sine x, the graph is a continuous wave. Okay, it's a continuous wave. It's oscillating between -1 and 1. Okay, so if I want to, let's say, okay, let's go to GeoGebra. GeoGebra. Let's say y is equal to sine x. Okay, so it's oscillating. Okay, it's oscillating. Okay, so wait. Oh, okay. If I have this point, y is equal to 1. So at this point, y is also equal to 1. But the x is different. Different x, let's say that's x1, that's x2, let's say that's x3, right? We have different x, x1 not equal to x2, not equal to x3. But we have this, let's say this y1, this is y2, this is y3, okay? But y1 is equal to y2 is equal to y3. Okay, does that make sense? Yeah, okay. Same with tangent, okay? Same with tangent. Cosine, same thing, okay? So basically we can get the formula, but don't worry about this formula too much at the moment. Sine x plus 2 pi basically is equal to sine x. Does that formula make sense to you? Yeah? Yeah, Ethan?
What formula?
This one.
Oh.
Cosine x plus 2 pi is cosine x, but be careful for tangent. It's x plus pi is equal to tangent x. Okay? Because it's a periodic. Okay, now let's have a look at the question. Cos 7 pi. Any idea how to solve it? No one? No? Okay. Because, okay, do you remember for sine and the cosine, one period is 2 pi. Okay, one period is 2 pi. Basically, okay, if I have, let's say, let me think about how to explain this. Let's say if I want to find a number here, wait. if I want to find a number here, okay, because it's periodic, the y value is same with here, right? If I draw a line, same y value, but different x value, right? So can you figure out the distance between the horizontal distance between these 2 points?
2 pi.
Good, 2 pi. Okay, so basically we can say if that's x, if this distance is x, okay, sine x is equal to sine x plus 2 pi, because their y value is the same, right? Now, cosine 7 pi, that's really hard to find, right? But we can minus 2 pi. Cosine 7 pi minus 2 pi, which is equal to cosine 5 pi. Okay. Can we minus another 2 pi?
Yeah.
Yeah, so cosine 5 pi minus 2 pi, which is equal to cosine 3 pi. We can minus another 2 pi. Cosine 3 pi minus 2 pi is equal to cosine pi. Is that easier to figure it out? Cosine pi is equal to, can anyone remember the graph? The cosine graph? Something like cosine graph. That's 0, that's pi on 2, that's pi. Good. That's 2 pi. Oh, sorry, yes, that's 2 pi. That's 3 on 2 pi, that's 2 pi. So 1 or negative 1?
Negative.
Yes, so cosine pi is equal to negative 1 is equal to cosine 7 pi. Does that make sense?
Yeah.
Noah? Sean? Yeah, okay. So you just need to minus 2 pi until you cannot minus another 2 pi. Remember the graph I asked you to memorize? Use the graph, negative 1, problem solved. All right? Okay, let's move on. Okay, don't worry about the differentiation because we're going to learn the differentiation in module 7, but don't worry about this. Don't worry about how to differentiate this, but I can tell you after you differentiate this one, f dash pi is equal to cos pi e to the power of pi minus e to the power of pi negative sine pi over cos pi to the power of 2. Okay, now the question is, can you simplify this?
You cross out all this. Make it
Can you cross out cos?
and bottom part is bottom is only 1 cos. It's square.
Also negative sine pi over cos pi.
Okay. Can you cross? Can you cancel out? Can you cancel out this cos, Ethan? Can you? Noah?
Think. Yeah.
Wait, no, because it's times by e
Yeah.
to the power of pi.
Yeah. It's negative. That's minus. See the minus? There's no common factor. If you cross this, oh, geez. Go back. Okay. Algebra again. You cannot cross out the cos pi, but you can only substitute the value in. Okay. So cos pi is equal to the graph. Good. -1 e to the power of pi minus e to the power of pi, negative sine pi. That's a sine graph. Here is the pi, which is
0.
0. All right. Again, cosine pi is -1 to the power of 2. Okay. Which is equal to negative e to the power of pi. Okay. That's an exam question. Okay. In the exam, you won't see any question ask you about what the cosine pi equal to. You won't see any like individual question ask you what pi cos pi equal to. They will integrate this kind of knowledge into that kind of question. Does that make sense? Yeah. If you want to solve this, you must know what cos pi equal to. Okay. Yeah. Yeah. Okay. Okay. Let's move on. All right. This is tough. I know this is tough. I know this is tough, but I'll use graph to help you to memorize this. Okay. How to memorize this. Okay. I'll give you an example about a sine graph. Okay. I think we discussed this before. Let's say we have a point here and a point here, right?
Redrawing.
The blue dot, point here and a point here. They have different x value, but the y value is the same. Is it? Okay. Because it's a symmetry, we have this point here, this point here. They have different x value, but they have same y value. Okay. Okay, I'll write it down. Okay. Pi on 6 and 5 pi on 6 have same y. Okay. 7 pi over 6 and 11 pi over 6, they have same y. Okay. But these y, they have same magnitude. Right? They have same magnitude, but opposite sign. One is like +1, one is the -1. All right. Same with the cosine. Okay. So this point and this point, they have different x value, but same y value. Okay. This point and this point, they have different x value, but same y value. Right? And the magnitude of the y value is the same. Okay. That's the same. But one is a positive, one is a negative.
Yeah.
Does it make sense, Sean? Noah? Okay. Okay. Why we discuss this? There's another table. We call 30-degree family, 45-degree family, and 60-degree family. Okay. So basically, 30-degree family means we start from pi on 6. Okay. If we know pi on 6, we know 5 pi on 6, 7 pi on 6, and 11 pi on 6. Okay, can you remember what pi on 6 equal to?
30.
I mean, let's say sine pi on 6 equal to. Sine pi on 6.
That one table.
Yes, yes. Sine, remember the table? This table? Yes, 1/2. Okay, so if we know sine pi on 6, if we memorize this sine pi on 6, it is equal to 1/2, then we know all these y values. Okay,
I think you still remember. Me, yes, you practice. No, I just remember.
okay.
Use it for so long, I forgot.
The why we have this? Because we have this graph. Because we have this graph. So see that pi on 6?
Oh, this graph is what the table is.
Yes, so see the pi on 6? Pi on 6, 5 pi on 6, they have exactly same y. Okay? 7 pi on 6 and 11 pi on 6, they have exactly the same y value. But for this group and this group, the magnitude of the y value is, yes, toilet? Yeah. Go. The magnitude of y value, same, but the sign different. One is positive, one is negative. Okay? That's why we have this positive, positive, negative, negative for sine. Positive, negative, negative. Okay. Basically, if I draw the graph, sorry, I'll draw it here. Okay, if I draw this graph and I divide this graph into 4 sections. Okay. So in this section, the sign value is positive, right? In this section, the sign value is a positive. In this section is negative, this section is negative. Okay, that's why we have positive, positive, negative, negative here. Does that make sense?
Yeah.
Yeah, okay. For cosine graph, I'll just draw it here. For cosine graph, it's something like that, right? Again, we divide it into 4 parts. Okay, that's positive, that's negative, that's negative, that's a positive. So that's why we have this positive, negative, negative, positive. Does that make sense? Noah, you good?
Yeah.
Yeah.
Oh, the tangent is that.
Tangent is the positive, negative, positive, negative.
Yeah. I know how to draw that, I think.
Yeah, does that make sense?
Yeah.
Yeah. Okay. Now let's try a question. Evaluate 2 pi on 3. Okay, 2 pi on 3. Basically, we can do this. Two pi on 3, let's say sine 2 pi on 3. Can you identify which family this one is belong to? 60 family, right? Basically, we can find, if we know, because it's in a 60 family, we already memorized sine.
It's 102. Oh no, it's what? Yeah, it's 1.
Okay, we already memorized this table. this table, which sine pi on 3 is equal to square root 3 on 2. Okay. Okay, this is the step 1. Now, we need to figure out the sign, positive or negative sign. For sine graph, it's a positive, 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 negative, negative. All right? So basically, that's a positive, positive, negative, negative. So is that positive or negative?
Positive.
Positive. Good. Okay. So
How?
that's pi on 3. That's 2 pi on 3. 3 pi on 3, 4 pi on 3, if I'm correct. And yes, and 5 pi on 3. So we pick this one, positive. So number 3, sine pi on 3 is equal to sine 2 pi on 3, which is equal to square root 3 on 2. Does that make sense? Ethan?
What?
Does it make sense?
What? Oh, is that the table?
Yes. Yes. Does it make sense?
Oh,
Noah, does it make sense to you?
so.
You think so? Could you please explain this to Ethan?
Yeah.
Why?
Um,
No. It's good for you as well.
Because it's 60, it's over pi over 3. But it's in the 60 family.
Yep.
And pi over 3, even the sine is like root 3 over 2. So sine 2 pi over 3 is also root 3 over 2.
Mm-hmm. What about the positive or negative sign?
And it's positive because sine graph is like that. Because you know when you're in the unicycle at sugar to coffee,
Yeah.
like
Yeah.
so A starts at 0 and then S is ends at 180. So that's kind of like the same thing there.
Yeah.
Because that's why it's positive.
Because 2 pi over 3. 2 pi over 3 and pi, which one is bigger?
2 pi over 3. Is it a true question?
Okay.
2 pi over 3 is it?
2 pi over 3 is it bigger than pi or is it smaller than pi?
Oh, we meant pi over 3. Oh no, it's less than pi.
It's a smaller, sorry, 2 pi over 3 is smaller than pi, right?
Yeah.
So this is the sine graph. This is the sine graph. And here is the pi. Anything between 0 and pi, positive. Okay. Any number between pi and 2 pi, negative. That's positive. Right? Does it make sense, Ethan?
Oh yeah.
Yeah.
Pi is negative in ENC.
Yeah.
DNC.
Like the unit circle. You know when tan is positive and cos is positive, sine is negative.
Oh, it's actually.
Remember all schools.
Teach crap.
Yeah.
Yeah. Does it make sense, Ethan?
Makes sense.
Okay, stop drawing on the whiteboard. Okay. Okay, does it make sense? Okay. Okay, Noah, I really encourage you to explain some concept to Ethan. Okay, because this is not just helping him, it's help you to understand the concept. It's called peer study. It's called peer study. All right?
Yeah.
Yeah, peer study. Now, on the mini whiteboard, okay, I'll write this. I will write the question down, and I will show you the table on the screen. Try to do it by yourself. Okay. Evaluate. Okay. I'll write the question on the whiteboard, and I'll show you the table. Show you the chart. The table on the screen. Just give me 1 second. Evaluate. Okay. Sine.
√2 2.
Give me 1 second. Okay, table is here. Don't worry about this. No, you already done the first one,
Yeah,
which is
2 √2.
√2/2, right?
Yeah, it is.
Yeah,
Oh,
good.
yeah,
√2/2.
yeah,
Yeah,
√2
good.
Is the second one 1/2?
Think about the sign, positive, negative
Or
sign,
negative?
negative, right?
How big is like me or how I was asking?
Okay, Noah, could you please explain that too?
Alright, so for the first one, that's the same as just writing 3 pi/4. And if you like take out the 3, like pi/4 is like sine 45 degrees, and back on the table of values, like what's sine 45?
Oh, you take out, oh, it's the 3. Okay, so that's why you take out the 4, take out 11. Okay, you take out, okay, yeah, I see. Yeah.
Yeah. What about cosine 11 pi on 6?
Oh, 3/2.
Square root 3/2, right?
Script. Oh yeah, that's one. Sorry.
Yeah.
Yes. If the last one is √3,
Yeah, it is.
Positive or negative?
What is positive, right?
oh, negative,
Why negative?
but it's got an asymptote or something.
Those are asymptotes.
Remember, for the tangent, we only have positive, negative, positive, negative.
Positive, negative, positive, negative.
Yes.
Also,
So see that tangent sign, only first and second only, so positive and negative. And for this one, for this one, it's which family? It's
also same but negative.
it's 2 on 3, which is 60-degree family. 60-degree family is which is square root of 3, but it's
Negative.
negative. Okay, so basically that's positive, positive, negative, positive, negative.
Yeah.
Yeah.
And yeah.
Ethan, you good?
No.
No?
I know how you do it, but I don't know where you get positive, negative.
Positive, negative?
Yeah.
Okay. Don't worry. I use sine graph as an example, okay? That's sine graph. Right? That's pi,
Mm.
okay? Any x value between 0 to pi, they are all positive.
Okay, yeah.
Okay?
Right.
Any value between pi to 2 pi, that's 2 pi. These are all negative.
But
Okay? And then if I divide it into 4 sections, okay, 4 sections. Let's say that's section 1, section 2, section 3.
positive, positive, negative, negative.
Yeah, that's positive, positive. Negative, negative.
Yeah.
Okay, if we look at this table.
Yeah.
If it's a sine, okay, let's say sine pi over 4. Sine pi over 4, definitely positive. Sine 3 pi over 4, positive. Sine 5 pi over 4, negative. Sine 7 pi over 4, negative.
Oh, I see why it's negative.
Mhm.
Because 2 pi over 3 is negative.
Yeah.
Oh, wait, that, oh yeah, yeah. Wait, no, you know how you said that? You say you cross it out, you don't cross it out.
Cross what out?
It's like you put the pi over here, right?
Yeah, it's the same. Well, Brian.
Oh,
So like, see how it's 3/4 and then the pi's next to it.
yeah.
That's the same as 3 pi over 4, because there's still multiplication. It's just multiplication.
Okay.
Even if pi was in front of the 3/4, it would still be 3 pi over 4.
Okay,
Oh, you didn't remember MC.
Yeah.
That's how you get negative.
so basically,
Oh, I think I get it.
yeah,
Got it.
okay, let's say 3 over 4, 3 pi over 4, okay? 3 pi over 4 is somewhere here,
Positive.
okay? Pi over 4 is somewhere here. Right? They have different x value. The x value, they're different.
Why what is saying?
Y value is the same. Okay, let's say 4 pi over 3. 4 pi over 3 is more than pi, right? It's bigger than pi.
Yeah.
Okay. 4 pi over 3, let's say it's just somewhere here.
Right.
Okay, and we have 5 pi over 3. It's somewhere here. They have different x value,
Same y value.
but same y value.
Is it in the same family?
Yeah, same family.
Yeah, same family. And the magnitude
It's the same.
is the same. But this is a positive, this is a negative, but the magnitude is the same.
Yeah.
That's how we get that table. Does that make sense?
Yeah.
Yeah. Okay, cool. Okay, now next one. I'll ask you guys to do it by yourself. This, I'll give you some hint. Okay, the hint is. Oh, okay. Can I rub this one off?
Yeah.
Yeah. Okay, I'll rub this off. Okay, and I will copy the question. Yeah. Okay, let me copy down the question on the whiteboard. Okay, the question is evaluate cos 17 pi on 3. Okay. And that's the table. I'll leave the table here. The hint is.
Why not 3?
That's the hint. Remember that question we done before? Okay.
It's 17.
Yes, there's no 17.
What's positive 1 over 2?
Think about this.
Yeah, it's
positive one.
It is just positive 1 over 2.
is you just gotta keep doing like you do 17 pi over 3 minus 2 pi over 3
Mm.
and keep doing that until you get to 5 pi over 3.
What do you keep doing?
Which is like so in a half over there, like there's no 7 pi.
Yeah,
Like
there's no 17 pi.
there's no 17 pi. Like that one before, we had to keep minusing 2 pi until we couldn't minus it anymore.
Okay.
Right. It kind of do the same for that, but instead you just do it 2 pi over 3. So 17 pi over 3 minus 2 pi over 3 is 15 pi over 3. Keep doing that until you get to there. Like until you can't do it anymore. Which gets just to plain pi over 3.
You get the remainder.
No, right, but like after minusing 2 pi over 3, like as much times as you can, you get to pi over 3,
Okay.
which equals well, it's just positive 1 over 2. I think I explained that poorly, but
It's nearly, but it's you just made one small mistake.
do you not have to go all the way to pi over 3? You just go to pi over 5 pi over 3.
You 5 pi over 3.
Yeah,
That's correct
or
explanation.
you don't have to go to pi over 3. You just have
Because 5 pi over 3, can you minus another 2 pi?
yeah, you get 3 pi over 3.
But that's not 2 pi.
Oh yeah.
That's the misunderstanding. That's the misunderstanding you have. Okay.
Wait, so what do you mean by that?
Okay. Right. Let's do this together. Okay. So we have cos 17 pi over 3. Remember the 2 pi? You can only minus 2 pi for sine and cosine. You cannot minus pi.
Yeah.
Okay. Basically, that one is equal to cosine 2 pi plus 2 pi plus 5 pi over 3.
So what 4 pi plus
So you cannot say
Minus.
you can minus 2 pi, but you cannot minus 5 pi.
yeah.
Okay, so basically remember that one. This one is equal to cosine 5 pi over 3.
Oh, so you don't have to keep minusing 2 pi over 3 until you get to pi over 3.
No,
Just
Because-
until you get to something in that family.
5 pi
But
minus 3.
that family,
Okay,
that
wait.
family,
Sorry for the interruption. Okay, 5 pi over 3 minus 2 pi.
What about 2 pi over 3?
2 pi over 3?
Like keep it the same denominator.
No, you can only minus 2 pi.
Oh, okay.
wait,
Okay, that's the misunderstood you.
wait, what about family? The family is 4 at the bottom.
Yeah, okay. Okay, just give me 1 second. Does it make sense?
Yeah, okay.
You can only minus 2 pi for sine and cosine.
Yeah.
And you can only minus pi for tangent.
Yeah.
You cannot minus 2 pi over 3 or pi. Okay? Because 2 pi is 1 period. Okay?
Yeah.
Pi is not 1 period. That's the biggest misconception
2 pi.
you had. Okay, you can only minus 1 period to move the second period forward, to move the third period forward, but you cannot move half of the period. The value change.
Yeah, okay.
Okay, does that make sense?
Yeah.
Okay. Now, how to evaluate cos 5 pi over 3?
Just
I think you just said that.
get rid of the 5.
How to evaluate 5 pi over 3? Think about here.
Cos family,
Yes, it's cos.
which is the third one. So,
So it's 60-degree family, right?
and wait, no,
5 pi over 3.
yeah,
And it's a cosine.
also 7 pi over 4 because this is the fourth one on the.
Okay, so okay. Noah. Sorry, Noah, do you know how to solve this from here?
Yes, so in the like say the cosine thing in the middle on the right, like it goes plus minus minus plus.
Good.
And if you go look at the 4 things there,
Yeah,
pi over 3 is the first one, so that's positive.
okay,
2 pi and 4 pi over 3 are going to the negatives.
yeah,
And then 5 pi over
that's
3 is the
positive.
positive. Yeah.
Wait, yeah, okay, that makes sense.
Okay,
Makes sense.
so can you tell me, is that positive or negative?
Positive.
So it must be positive.
Wait,
Positive something. Now,
okay, yeah.
okay, cosine pi of 3. Let's go back to that table.
That's positive.
Okay, cos pi on 3, which is
1/2.
1/2. So it's a positive 1/2. Does it make sense?
Yeah,
Yeah, you sure?
yeah, that is.
Yeah.
I don't know why.
You don't know why. Remember I shouldn't rub it off.
I just do it. I just do it.
Remember the graph I just drew. Okay,
Yeah,
different x but same y value.
yeah.
Different x but same y value.
Yeah,
Okay, so the same y value. That's negative y. That's negative y.
yeah,
That's how we get that table.
yeah. Okay.
Okay. Okay. Let's move on to the next part. This is the last bit. Last bit for the day. Okay. I think I'll leave this as a homework. Try to do it at home. Okay. Oh, wait. I need to write this down. Okay. This is for homework. Okay. Don't worry about how we get this part, You just start from here. Okay?
That will work.
That's homework. Okay, and I will,
What's that homework? You substitute something.
yes, you just need to evaluate sine negative 2 on 3 pi. Sine pi on 3. That's the point for this question. Okay. Sine pi on 3 is equal to something.
You figure out both and that's it.
Yeah,
You can't use calculator.
you can, but don't just,
Divided by pi.
yes. That's definitely not hard. It's just the algebra.
Figure it out.
Yes, it's just the algebra. Okay, that's all for today. Okay, any questions? No, Sean, you good? Okay, cool. Any question? Feel free to ask. Okay, and you're free to ask any question in class. In my class, no stupid question. Okay, no stupid question. No silly questions.
What's that?
Silly questions. Okay, no silly questions. Ask any question you have, right? Because you're learning.
Wait,
Okay.
I understand everything. I understand how you get the value, but I still don't really get like negative and positive.
Okay. Just stay. Okay. Feel free to go. Okay, Ethan, I'll explain that.
But I think one of them actually know how to get negative positive. Was it this one? I think he explained it with. What is it? Good. You just look at the.
If you don't have questions.
Look at the family thing.
Cosine is always the cosine. It's plus negative plus.
Yeah.
Just think about that.
Oh, it's like the results that here. That you,
So if it's pi over 3, it's positive. It's I forgot the
2 pi over 3.
2 pi over 3 negative, 4 pi over 3 also negative, 5 pi over 3.
yeah, you remember the
Positive.
family.
If you remember that, and then sine is plus, minus, and then tan, because they're like that, those ones, it's just plus and minus.
Oh,
So it's just that. Just think of it as that.
yeah.
It's that, but it's also that.
Yeah. Makes sense.
Yeah.
Yeah,
I think
You
yeah,
understand it?
yeah. You just create this number and you click on top. Yeah.
Yeah, just you can remember that.
and how to get the number? Okay, that's the positive or negative sign. How to get the number is based on the table I showed you
Yeah.
previously.
Well, yeah, you put this on top.
Yeah,
Yeah, but I get it. I think I get it.
you do agree.
Yeah,
You sure?
yeah.
Okay.
Thanks, Noah.
Thank you, Noah.
Yeah.
Good.
With thanks,
Practice.
Sam. Okay. Oopsie. Oopsie. Wait, I don't remember Peter. Is there a Peter here?
No.
It's no Peter.
Okay. Oopsie.
Yeah, it's
Must be your like school. Alright. Then you need to practice.
Yeah.
Okay, you need to practice.
Wait, did I miss the last lesson? It was like that.
that was module 1,
What's module one? Oh,
the
yeah.
polynomial.
Right. Isn't that just covered in the text, or like in the context?
Huh?
In our
Yeah, that's it's basically what we did this semester, but the next
in our
the term of next year.
right. You're right.
But okay, Ethan, come. Fraction.
You cross something out.
Thank you, Sam.
That's all right. Have a good night.
Yeah, you too.
You cross. Oh, this is how I do it. You what? Yeah, yeah.
Yeah. Yeah.
Oh.
Next time. Okay, this is basically that.
Mm-hmm.
Skip that process.
Oh, yeah.
Skip that process.
What? So, yeah. That. Not that. What? What do you do?
Think about how you cross it.
Like, oh,
Why? Okay.
they could simplify it. Cross one time. Okay, yeah. Oh, okay.
No, this one.
Oh, but how would I do that? What I do?
Okay. You don't need to skip this process for now. But after you practice, I hope you can. Mhm. Mhm. Mm,
Whether I write x equals or not, I just do this.
No, that's it.
Okay. Yeah.
You need to practice. For me,
You skip the whole process. Okay.
I hope you can skip the process at the end.
Okay. Yeah.
Now you can do that. But after you practice,
Oh, yeah. Oh, but now I see it makes sense why you did that. Okay. Yeah. Thanks so much.
that's all
Yeah.
right. It's nothing but practice.
Yeah.
The reason I can do that much quicker than you is just because I practice more.
Yeah.
It's nothing special. Nothing special. Okay? It's not because you don't understand the concept. You understand the concept.
No practice.
It's just a practice.
Mhm. Yeah, then.
See ya. Hello，搞定了。
这个我也没看到。Memory card 和 memory 那么多啊？对，它正常是这么多的。哦，咱们只想到26、27张。对的。这个在我的那个 YouTube 上面，你可以看的。其实。
这个我先放这儿了。
耶，
讲完了，正好第一节课讲完。
好的。
的话完全没问题。1份稍微有一点 struggle，但也还可以。上我觉得也还可以。